Apply the row operation to the augmented matrix. This notation means that we're going to be replacing row 2 with this combination of the current rows. And when we replace row 2, we actually are not going to change row 1. So the new row 1 is going to be a copy-paste of the old row 1, and old row 1 is simply row 1 from the previous iteration. So we would copy-paste old row 1. Now we're going to create a new row 2 by taking -3 times old row 1 and adding that to old row 2. And if needed, we can kind of open that row operation up, which might make our calculations a little easier. To get our first column element, we're going to use the first column from the previous iteration. Our row operation says that we want to take -3 times row 1, and the row 1 element was +1, and then add that to row 2, and the row 2 element is +3, so we end up with -3 plus 3, which is 0. And that's our first column element in this new row. To get the second column element, we're going to use the second column from the previous iteration. We're looking at -3 times row 1, the row 1 element is -2, and then we're going to add that to row 2, and the row 2 element is -5. So what we have here is +6 minus 5, which is +1. So +1 is the element that goes in the second column position. Let's do this again for the third column, and again we're going to be using the elements in the third column from the previous iteration. We're looking at -3 times row 1, so the row 1 element is 2, and then we're going to add that to row 2, and the row 2 element is 9. So we have -6 plus 9, which is +3, and +3 is going to be our last element. Let's finish this by adding our augment bar, and this will be complete. When we're asked to change row 2, the implication is that row 1 doesn't change, and we write a completed matrix with the same row 1 from before and this change to row 2 having been made.